Hey, so in this tutorial we are going to control this smart car from TouchDesigner using these 5 buttons here. I wanted to make this mainly as a generic guide to Arduino and TouchDesigner projects. I didn't necessarily choose this with the idea that you guys would buy the smart car that I bought and follow along with me. I more wanted you guys to see the steps you need to take for any project between the two and make it work. So that's what we're going to be doing today. I appreciate you guys for being here. I hope this helps you guys learn TouchDesigner and Arduino. Alright guys, so the first thing we got to talk about with any sort of project with Arduino and TouchDesigner is how we're going to connect the Arduino to TouchDesigner. If we were going to get fancy schmancy, I would use Bluetooth, but I don't want to overcomplicate things right now, so we're going to use a wired serial connection. So you can see right here, we're not going to get fancy, we're just going to do a wired connection. That's how we're connecting to TouchDesigner. But it's always a good thing to think about first. So step 1 done, we've decided how we're connecting our controller to the car. Good job. Step 1 done. Step 2 now is understanding what's going on the Arduino itself and how it's moving. And now Elegoo makes this really easy. They gave me all this source code. I love them for that. So I'm just going to go to the first one, auto go. Let's check this out. So I love comments like this. This is very helpful to me. So this little table here is describing to you what state each of these input-output pins need to be in order for the car to move in a certain direction. First off, the 2 enabling channels need to be on for the car to move. If the 2 enabling channels are off, nothing's happening. Or if they're all low or high, nothing happening. Car be stopped. Okay, so that's great. Thank you so much for this very informative comment section. And then we go down further. And this is going to define, and then we're going to define the pins. We're actually defining literally where they are physically plugged into the Arduino. Pin 5, pin 6, pin 7, pin 8. This software, this code is actually corresponding to a physical spot on the Arduino itself. Pin 5, pin 6 are our enabling channels, and the rest are going to our inputs on the motors themselves. Okay? And then we have our predefined functions. One for forward, that's going to set all of the pins where they need to be in order for the car to run forward. And it's going to do the same back. We're going to set the pins to what they need to be for the car to go back. So then these are all our predefined functions, and then we see our setup function. This is where we're going to set up our pins and set up all of our stuff. And then this is where we're going to repeat our execution, just like they say here. So for this code that we're analyzing right now, we can see our main function, or our loop function, is just going to have the car go forward for a second, go back for a second, turn left for a second, and then turn right for a second. That's it. Basically what we just learned is all we need to do during our loop is listen for a signal from TouchDesigner. Then we need to analyze what that signal is telling us, and then based on what the signal told us, do something. In this case, if I was doing this in real time and thinking out loud, I would say, okay, well, if I need to call a forward function, then I need Arduino to know that TouchDesigner wants me to move forward. So I need to create code that's going to allow that to happen. So that's our next step, is writing new code for the Arduino that's going to take in signals and instructions from TouchDesigner. Alright, so that's our next step. step 3, now we're going to start to write the code that's going to create this whole system. Basically, we have everything that we saw before. We have our nice comments so that other people can understand it. But basically, we're going to define our pins. We have our car speed. It's the only thing that's different here. So everything here is for the car itself, right? This setup buffer section, that's for communicating between the serial port and the Arduino, right? And then we have our predefined functions like we did before. We have a stop function now that I think that's new. And you'll see that the stop takes no parameters, doesn't need a speed, it's 0. And then once we get into setup, we're going to open our serial port, we're going to send a message, and then we're going to tell the Arduino what to expect in these pins. So after the setup, it's going to enter its first loop, and it's going to wait. And if there's a message coming through the serial port, it's going to do all this. If there isn't a message coming through the serial port, here's the end of our if, don't do anything and just keep looping. So say we send, like it says up here, say we send through our serial connection an F and a 100, right? It's going to say, oh, there's something there. And it's going to come in here. It's going to store whatever's coming in as a byte. And then the buffer is going to store that incoming byte in its array. And we're going to check for an overflow. Make sure that it's not too long for the length that we've set, which was 16. And then we're going to check for the new line character, which we've just decided unspokenly that will be trigger the end of a message. So once we read the end of the message, then we know that a full message has arrived. We have a direction and a speed. And then we're going to declare our two variables, a character that's going to tell us the direction, and a number that's going to tell us the speed. And then scanf function is going to scan in from the buffer, and then it's going to take the char and the int and pass these values, and set these variables to the values coming in through the buffer in those positions. So C, F is going to be the direction, and then whatever here, probably 100, is going to be saved as our speed. And then we're just going to do a little check. N, so scanf returns a number, and that number is how many things it scanned. So we're expecting 2 because we're sending an F and a 100, and then the new line character. So N should be 2 if we've sent this correct number of parameters and variables in through the serial port. So we just want to do like a little check here. You don't have to do this, you can just assume, but it's always good to error check. So if you only send in a direction without a speed, or you only send a speed without a direction, then N is not going to equal 2, it's going to equal 1, or 0, or 3, or 4, or 5, and then it's going to go down to the else section of the code. It's going to print to the serial port that there's an error and you didn't send the right stuff. Then the length is going to be reset, and we're going to go back up and loop again, and it's just going to keep waiting for a new message. But if it is the correct number of parameters, then we go down to our switch statement. And here we're going to take in our direction variable, and if it's an F, we're going to print to the serial port that we got a command to go forward. Then we're going to run the forward function and pass in our speed, and then it's going to break, and it's going to go down and set the buffer back to 0 and loop around again and wait for another signal on the serial port. So we're just going to upload the code, And then if we turn on our serial monitor, we see that it's listening. It's right here. It's in this part of the loop. Right now, serial.available is returning 0 because there's no message. So it's taking this, and we're just going down here, just looping over again, looping, still false, still false. We're going to test this with the serial monitor on Arduino because I want you guys to understand that this is the same thing as this in TouchDesigner. The serial node is literally just a serial monitor. That's it. So now we want to test this out. And I'm going to do it on here so that you guys can see that we do not need TouchDesigner to control the Arduino. So I'm going to send F. We know that's not right. We should get an error, so let's check our error. Good. We got a parsing error. Incorrect number of parameters. That is exactly what should happen. So now we press. Let's give it a speed like we should. Good. It's going forward like we expected it to because it received 2 parameters. We got the switch. We heard an F. We went forward. Ba-boom. So now this, technically my car is still moving forward. But I'll send a stop. And it stops. Boom. I will turn the car on just so you can believe me. But, so we'll get so F 100. You'll hear the car wheels turn. And then I'll send a stop. And the wheels stop. I'll have visuals for you in the next section. But okay, so that's it. That's step 3. We've created new code on the Arduino that's triggerable from the serial port. And we know that it works completely separate of TouchDesigner. We've troubleshot it. We know that an error comes through when we expect an error, and that the switch works, and that the switch is telling the Arduino to do the right thing under the right circumstances. So we're good to go. On to step 4, where we finally integrate TouchDesigner and do this from TouchDesigner. So we're going to go here. We're going to get our serial DAT. Here it is. Alright. So we've got our serial 2 DAT, and then what we need is a text DAT to put our code in. It's written here already what we need. If we go up here, see that? Boom. Let's get that. It's actually going to be serial 2 copy because I'm just testing right now. So see how I have serial 2 here? You can see that, guys? I gotta make sure I switch that. So serial 2. So we've got it. It's listening. And then all we have to do to test, this is just one simple test, guys. We're gonna right click on the text DAT, run script. Boom. Okay, see? It's getting forward. But then we're going to send stop. Run that script. Stop. See? Boom. Done. And we know that it's working. You can't hear the car because I don't have the car turned on right now. But that is exactly what we want. So I'd say that step 4 is done. So now let's do the fun part. Create a controller via TD. So all you need to build this is get a serial DAT again, set the COM to 3, I'm going to leave it off for now, and then instead of a text DAT we're going to grab a comp button. So we have this button here, and we'll say let's do test forward as the label, and then we're going to have a merge chop. So wait, did you guys see what I just did there? I just right clicked right here on the output. New layout. Where's merge? There it is. Okay. So we've got this puppy. So then you can see that when this, click it, and it changes the value from 0 to 1. Alright, and then we need a chop executable. There it is. Alright, so one thing that can really screw you up is not understanding that these, all of these functions refer to a button over here. So if these aren't on, if we don't set these to on, then none of these are going to run. So right now, the only one that's on is value change, meaning that anytime this happens, whatever's in this code here is going to run, is going to be triggered. I want on to off, off to on, and on to off on, just because I wanted to say that I wanted to do two different things. When it goes off to on, I want it to go forward. When it goes on to off, I want it to stop. So all we're going to do here is say paste the same thing here. We want our serial 1. Oh, do we? No, we want our serial 2. Node to send a forward character, and then our speed, which is 56, which I'm pretty sure is too low for the car to actually move. I think it needs to be up to 100. If you guys are having trouble with that, I think it's just because your speed's not high enough. You'll hear it whirring and it won't be moving. So just put it up to 100, and then we're gonna go down here, and when it goes off onto off, we're going to send a stop. And the speed doesn't matter with stop, since the stop function in the Arduino code that we made doesn't take in any parameters, so it really doesn't matter what speed we put in. See how stop doesn't take in any parameters because it doesn't care about the speed, because it's definitely going to be 0. So this value that you send when you're sending the stop character doesn't really matter. But if it's going to bother you, I will put a 0. Just for you. Alright, so that's all done. So we've written our trigger code in our chop executable. We've set it to send the message to this serial DAT. So now anytime this button goes from on to off, it's going to trigger this code here and send an F character and a speed of 100. And anytime this button changes from on to off, it's going to send to the serial 2 DAT an S character and a speed of 0 with the terminating line, so that the Arduino knows that the message is finished. So if we turn this on, right, we see that it's listening because the Arduino has power. And you'll be able to hear, you'll be able to see, but you'll be able to hear my robot moving. Alright, so let's go forward. So we should see, yep, and stop. I don't know if you guys can hear, but it's moving. So forward and stop. Cool. Alright, so here's the complete controller. And it's the same exact thing as what we did before with the test forward button, except now we're adding in a right, stop, left, and back. Stop is redundant because every time we change from on to off with any one of these buttons, is going to stop the car. But I think it's always good to have a stop button. So you can see like the right button, if we follow over here, all we're doing, guys, is we're changing what's going to happen when we're changing the parameter we send to the Arduino in the off to on function. We turn on off to on and on to off functions so that we know that those will trigger when the functions are fired. When this button's, so that's what's going to happen. So I want to make sure you guys understand them all. So I want to make sure I'm being clear and not jumping too far ahead. So this is the same exact thing we did before, except we'll use the back button as an example. We have this. When the button's turned on, we're going to go over here. It's going to change the value of the merge chop, and when the value of the merge chops changes to on, it's going to trigger this function here that says on to off to on, and it's going to run this function here that's going to send a B character and a value of 99 to the Arduino with the terminator character so that the Arduino knows that the message is finished. That's it. And then when it goes from on to off, we're going to send, instead of a B character, we're going to send an S character. And I'll change this to 0 for you guys, but this parameter really doesn't matter when we're sending the S character. And we're just going to make sure that you have off to on and on to off functions turned on each of these chop executables. Yeah, that's it. So I will actually, just so you guys, to make it really plain, so this is the back button. You can see I'm sending B in a speed of 99. This is what the right button's just going to send an R character, same speed. The left button's going to send an L character with the same speed. The stop button's going to send an S character with the same speed. And that's it. There you go. And I will demonstrate for you. Alright, so we'll go forward, back, left, right, and we'll test the stop button. Boom. Good to go. Okay guys, so that was the tutorial. I hope this helped you see how you could expand off of the other tutorials and what we did with the RGB LED. As long as you have the source code of what's running on the Arduino, and as long as you understand how you can trigger something to happen on the Arduino in the code, then you can create your own code, triggerable from the serial port, and then create your own app or your own interface on TouchDesigner. I hope it was helpful to you. If you feel like it, like and subscribe, and if you don't. Have a great night. Peace.